Good morning, ladies and gentlemen, and I'd like to congratulate you all on getting out of bed and turning up at this early hour of the morning. And thank you for that kind introduction, Professor El-Aziz. But you flatter me, I'm afraid. I'm not a professor, nor am I an academic, nor am I a doctor, nor a researcher. I don't work for industry. What I do is I represent patients. I represent patients and families whose lives are shaped by life-limiting and currently intractable diseases. And what I want to do in this discussion is to try and interject the perspective of those patients and families into consideration of the question of the right to proper health care. In the program describing this session, it says the right to proper health care is by no means a luxury, yet a right for each individual, rich and poor, old and young. Yet providing suitable health care is a challenge that faces decision makers. Well, my thesis is that it's not just a challenge that faces decision makers, it's a challenge that faces all of us, whether professionals or lay people, whether experts or amateurs. We are all citizens, and we all have a part to play in addressing the question of how we can answer the question. And it is a question. Is this, the right to proper health care question? Is there such a thing as a right to proper health care? So let's think about this. This notion of health for all. Now, for many people, poor health is not a choice. I know we have a rise of so-called lifestyle diseases, of type 2 diabetes, of obesity, of the things which are brought on by the way in which we live our lives. But the vast majority of people, given a choice, would not choose to be sick. They would like to be well. They would want to have good health. But our genetics, the opportunities that present themselves to us, our access to care, the level to which we're educated, the availability of the opportunity to make choices about our health will influence whether or not we develop or avoid preventable diseases. But the vast majority of diseases are still not preventable, and they arise from that either from genetic causes directly or from the interaction between our genes and the environment in which we live. But despite that, the hope for health is universal. I doubt there's anybody in this building who would, if asked the question, put up their hand and say, yes, I'd really rather be sick than well. It's not a choice we make. It's something that happens to us. And the reality for most people, wherever they are in the world, is that many are denied this hope for health. So my question, the question which I want to address over the next few minutes is, what can we do to respond to needs, and the word needs is important here, appropriately and fairly within available resources? And I'm talking mainly about public healthcare systems that are predicated on the notion of solidarity, that we are all part of a greater collective with a duty to respond within available resources effectively to the needs of the citizens who present them to us in a way that is fair, that is ethical, and that is equitable. Firstly, we need to think about what do we know and what do we need to know. And research is a hugely important issue, and supporting and sustaining high-quality biomedical research and its translation into interventions, into products, services, and support for patients living with intractable medical conditions is a vital component of the ongoing development of healthcare. And although we've made huge progress, some of the advances that we've heard about in this conference from in yesterday's plenary sessions, the speed and the accuracy with which we can now sequence the human genome, the developments in terms of many areas of medical care have been unimaginable to previous generations. If you think that within the lifetime of many people in this building, we've gone from understanding the crude structure of DNA to being able to think about personalized medicine with segmented interventions based on genotypic distinctions between populations with apparently the same disease. That is huge progress. And the curve, the rate of change, is increasing. We are learning more and more, faster and faster. But knowing what causes a disease is not the same as being able to cure it. You know, we might know what's gone wrong, but what do we do to fix it is the issue which we struggle with. But even when you have an incurable condition, research gives us hope for progress. But wherever we are, whatever point of the continuum from incurable to preventable, treatable, or curable, we need to manage the conditions that affect us in a way that reflects our current possibilities in the context of available resources. And the way in which we manage will be dependent on where we are in the world, on the healthcare system that we look to support us, and how we allocate the choices, how we make the choices that we make about what to do and what not to do in the context where demand is rising and the expectation that healthcare systems will do something is outstripping the opportunity for them to intervene because of demography, because of the opportunity created by new knowledge, because of greater expectation. You know, increasingly, patients and families are not content to accept what it is that the healthcare system says is good for them. They want to be part of that process of, you know, discussing and negotiating and choosing, particularly in the context where a condition is chronic, because, you know, by definition, it's about managing options. There is no cure that will take it away. And also the economic circumstances that underpin the access, the resources allocated to healthcare as compared with other opportunities. So there are new opportunities. You know, more diseases are becoming treatable or manageable, but some of these are at a huge cost. For example, inborn errors of metabolism, some rare inborn errors of metabolism like Gaucher's disease or Pompe's disease can now be treated. It's lifelong medication, enzyme replacement therapy that manages the symptoms and prevents further degeneration. But the cost per patient per year is very high. You know, should we pay it? Should we make that choice for that patient? Because just because something can be done, should we do it? You know, how do we, if not, why not? And how do we choose between those things which a healthcare system must do, and when it's done those things which it must do, we look at those things which a healthcare system should do, and then if there's money left over, we go into the arena of those things that the healthcare system could do. But it's a hierarchy of priorities that we must establish. And how do we choose between these different options? So the response that many healthcare systems are developing, and it's becoming increasingly important in many, many countries around the world, is to create the framework for decision-making that's known as health technology assessment. Now, the argument supporting health technology assessment as a tool is inexorable. You can't argue against the idea that healthcare systems need to know what works and what doesn't work. They need to know who it works for and under what circumstances. They need to know the cost of these interventions and what that total will be and how many people are going to require it in their population, so they can plan, so they can decide how they're going to deliver the service, is it worth spending the money on, and so on. And so forth. So, you know, the rhetoric is unanswerable. Of course, healthcare systems need a framework for deciding what they're going to spend their money on, that guides them to what seems to be the correct choice to make between competing and conflicting options. That sounds good, doesn't it? You know, a scientific answer to a question created by scientific advances. You know, that has got a nice feel about it, doesn't it? It kind of takes out the personal, the subjective, and you end up with a system that's fair, that's objective, that's replicable. So wherever you are, whatever the system you're in, you know, if you put the information in at the beginning and you turn the handle on the machine, out comes the answer at the other end. So, you know, surely we should be happy about this. Isn't this great? A fair, a rational, a scientific system. But, and you know, there is a but. From my perspective, from the end user, the patient, the family's perspective, HTA is not the complete answer. And the reason it's not the complete answer, as it stands at the moment, is that health technology assessment system measures what's important to healthcare systems. But what's important to the healthcare system, or to the clinicians or whatever, may not be the same as those things that are important to patients and their families. I'll give you an example. For many years, research to develop treatments for Alzheimer's disease has used as its endpoints in clinical trials those things which can be counted. Things like the preservation of intellectual capacity. But if you ask patients and their families who have Alzheimer's disease, what's important to those families, to the patients, it's about preserving the independence in daily living. It's about deferring for as long as possible the point at which you need personal care help to do those intimate daily tasks. So arguably, the research that has focused on preserving the intellectual capacity, on maintaining your awareness of the world in which you're living for longer, whilst your body degenerates and you suffer the impact of loss of independence and the increasing dependence on others to keep you clean and fed, is not doing anybody any favours, because you're preserving the awareness of what you've lost for longer than perhaps would have been kind. So, you know, you need to look at the things that are important to patients and their families, as well as those things which are important to healthcare system. So what do patients want? And patient expectations, if you like, there's this kind of cascade of expectations. You know, as I said at the start, nobody chooses, or very few people, I think, would choose to be ill as opposed to well. But when we are ill, you know, first of all, we want a diagnosis. We want to know what's happened to us. You know, why am I experiencing these difficulties? What's gone wrong? Then the next question is there a cure? Can you make it better? Doctor, can you cure me? Can you take away my problem so I no longer have to think about it? And if you can't cure it, is there treatment that will manage the symptoms? And again, you know, we think about the example of Alzheimer's disease, the treatments available that preserve the independence. You know, they don't stop the disease from happening, but they delay it and they ameliorate some of the symptoms. You know, is there anything we can do to prevent it, to stop it happening again? And this is an area where very often the genetics combines with the public health to look at individually based preventative options, genetic counselling and advice about reproductive choices, and the public health things about removing the environmental risk factors. But given that these things are very much dependent on the state of our knowledge and on the extent to which it's available to clinicians, what do patients want as well? They want information. We want to know, in a sense, what's the pattern, what's the trajectory of our disease? When can we expect things to get worse? Or, you know, do we need to expect things to get worse, and when will it happen? You take the example of, let's say, Duchenne muscular dystrophy, which is a rare muscle-wasting disease that affects boys. They gradually get weaker and weaker and more dependent, and at the moment they die in their usually in their early to mid-20s. Now, the day after a diagnosis of a boy with Duchenne muscular dystrophy is made, you know that that boy is going to need a wheelchair around about the time he's 10, 11, 12. You don't have to wait until he's gone off his feet and he can't walk any longer before thinking about that. You can plan it if you know it. So the information is important. And with the information, you can get the support, the advice, how are you going to manage these things which are going to happen to you or to your children. And most of all, it's important to feel that the healthcare system, the other services, are interested and are there for you. That if something can be done, it will be done. That you won't be put out onto one side as too difficult, too expensive, or too unimportant. You know, you need to feel that the healthcare system is interested and engaged with you and your family and your problems. Whether, you know, you've got something which is easily treatable or currently completely incurable, we all need to feel part of the process. After all, as a good friend of mine once said, you know, good health is just an incomplete diagnosis. Inevitably, we will all be patients at some point, and we will all need the help of the healthcare system. Hopefully, it will be there when we call on it. So for chronic diseases, there is no single way forward. And what we want to see is partnership with clinicians. This is about looking at what's important to the patient and the family and how best to achieve these, so that the healthcare system is fitted to our lives rather than having to fit our lives to the healthcare system that imposes constraints and restrictions on how it organizes itself, often for its own convenience rather than for ours. And we need to match up the aspirations that we have with the possibilities that exist in the context of the health technology outcomes process. So how do we do this? Well, first of all, we must have a dialogue. We must have engagement with patients and patient support organizations and the other stakeholders. So it's not the kind of old hierarchical model where scientists invented, doctors prescribed, patients took and were grateful whether it worked or not. But it's more a negotiation where everybody comes together to work out what is, if not the best possible outcome, what is the least worst outcome in the context of the life and the situation and the disease of the patient that's affected. We must recognize the expertise that living with the disease creates. And that is complementary. You know, my experience of being a patient is complementary to the experience of my doctors in terms of their understanding of my biology and what might be done to change it. We must develop plans that can be agreed on as realistic and negotiate honestly. You know, there is a great reluctance on the part of many people to actually face up to the truth, you know, that actually we'd love to do this, but we don't have the resources, or, you know, we don't have the expertise, or this is still very experimental, it might not work. You know, we need to know the limits of possibility, and we need to be able to set attainable metrics for progress. You know, if you don't know the journey you're embarked on, if you don't know how you will know when you've got there, if you haven't got a plan, an agreement, then how do you know you're doing things properly? How do you know you're actually using your skills, your knowledge, your expertise to the best available outcome? And you need to have regular reporting back so that everybody knows that we're still on track, and everybody knows that if things change, we can alter the plan. So, you know, the right to proper health care, it's not an unattainable goal, but it's not a license to address patients' wants. You know, I mean, I want lots of things. I don't need them. It would be nice to have them. But we must be able to distinguish between, particularly in a resource-constrained environment, we must be able to distinguish between those things that we need and those things that it would be nice to have, our wants. So we need a framework for meeting needs and setting priorities, and a recognition that scientific progress creates new problems as well as helping to resolve old ones. And this becomes a tool for equity-based planning so that we can make those difficult resource allocation decisions. We can know that the system has thought about these issues in the context of a framework that takes into account our views as patients, the views of clinicians, the views of the policymakers and the planners, the views of the scientists as to what is possible. And that decision-making framework is robust, that it stacks up when we look at it, and we might not like it as patients that the system can't do something for us, but if we feel that the decision has been made fairly and robustly, we're more likely to be able to accept it than if we think it's just an arbitrary decision taken by some official in the pursuit of vested self-interests, that the consequence of which is that we suffer and others make gains that are unfair and unreasonable. So thank you very much for listening.
Thank you very much. It's always a pleasure to be here. It's my 5th time in the BioVision now, and I really love this event that bridges north and south, east and west, and all the different various aspects of biotechnology, and especially what we are talking about here today, how to make it relevant for society. And thanks to Alistair, we have had an excellent introduction to all the major issues, or at least a whole lot of them in this field. And so my talk would probably be a next chapter talking about what kind of mindsets and paradigms would be relevant to address the kind of challenges that you so very well outlined for us, Alistair. So I will show you what the EU is working on. They are talking about the future and emergent technologies, and they have some flagship projects related to finding out about the future technologies. One is the Human Brain Project. They want to map and maybe even put a virtual brain in the computer so they can simulate what goes on in our minds. It's obviously a very interesting research. There is another project called IT Future of Medicine, which ambition is to find all the metabolist pathways in our whole body, from genes to the proteins and the clinical states. And there are Guardian Angels projects to look at robotics and so on, which we will also talk about here later today. So what is all this about? It's about trying to address the complexity of life, trying to understand the systems of biology with a systems approach, scientific systems approach, and to use integrated and cloud computing, massive computing power, to put all the data that we produce today, from genomics to proteomics and all the other omics, into the computer and try to integrate them. So we want these machines to also help us learn about these things. So the machines will try to emulate the brain's workings. And we will also possibly see that they are, since these are very dynamic systems, we will need to have an evolutionary mindset. That is my conclusion. So this is a very simplified picture of some of the metabolic pathways in the body, and this is what they want to map. And in the US, there is also a similar project, one of them called the Human Connectome, and you can see from the picture why that's a relevant name. Now, the Human Brain Project in the EU has this wonderful ambition of integrating everything we know about the brain into the computer models, and to use these to simulate the actual working of the brain. Ultimately, we will try to simulate the complete human brain. Beat that. The brain is supposed to be the most complex organization on the whole planet, maybe in the universe. We don't really know that, but among living things on the Earth, our human brain is probably the most complex. So the IT Future of Medicine wants to analyze all patients down to their proteins and chemicals and their own personal DNA sequences. So it's not about the human genome, it's about your genome, your personal genome. And on the basis of those data, a physician presumably, will be able to use a computer to quickly suggest individual advice or therapy. That's the ambition. And then you can choose which drugs or which health risks to address and the consequences of lifestyle changes and recommendations for diets and so on. These are the ambitions as I learned them in a meeting in Germany earlier this spring. And this is another simplified, oversimplified picture of the human connectome or the human metabolism. And this is what they want to put in the computer, and this is what they want to understand. And then we also need to understand the dynamics, because every link between every dot on this map is a dynamic link. It changes all the time by influence from all the other dots. And this dynamics is extremely complex and extremely interesting, of course, and extremely crucial for medical understanding and technology. So let me give you a brief input of what some Norwegian colleagues are trying to do. There is a Norwegian Cancer Genomics Consortium that was recognized in Nature, I believe in February this year, that is trying to develop diagnostic and personalized cancer medicine and treatment based on genetic analysis of the tumors, partly of the patient, but also of the tumors. So it's a network of different hospitals. They will do deep sequencing of the tumors. They will look at multiple cancer types and do all the bioinformatic tools and so on. And they have started a lung cancer pilot study with already 100 patients. And they study the relevant genes for tumors and try to identify them through bioinformatic analysis. So the overall picture of this is, as you see, 5 hospitals on this side are working together to collect data from their patients, which they send to sequencing, and the sequence is going for bioinformatics analysis into a national mutation database, which is connected then to the Norwegian Cancer Registry, a huge biobank and also epidemiological register, one of the most systematic in the world, I believe. So you can combine the clinical and the genetic data. And then possibly you can also address the kind of issues that I mentioned in the beginning of my talk. So to be able to do all this, you also need tools. And one available tool that this consortium is going to use is made by a Norwegian company called PubGene, and it's called CoreMine. So they try to address all these different aspects of the human metabolism. It's the relationship between all these aspects you see here, what goes on with the gene and the protein, and how does the molecule function, what the process does it add to, and then you can go to the cellular level, and you can go to the anatomical level, and you can look for the symptoms, and these things need to be connected. What genes are related to what symptoms? What genes are related to what metabolic pathways? We don't know very much about all this. Even given all the huge basis of information, we need to find the connection. And this kind of database connects knowledge from all these fields and try to highlight the relationships that we know so far. So these can be a starting point for further research to elaborate and look for those logics and the real causative effects along those pathways. So this tool is hopefully useful for many of you working in genomics. You get some kind of biomedical mind maps that relates articles and hits in the literature with the genomic data that pouring in from sequencers, and you can sort of then get a broader overview. So the endpoint that people talk about, this is the dream of a future healthcare based on a predictive, personalized, and preemptive medicine that can involve you, as Alistair indicated for us, in decisions about how to address your risk factors based on your own genes. So it's kind of reverse engineering of your whole metabolism as a person. You try to find out the details of what made you what you are, to be able to maybe change you to the better. Now, let's look at what other people think about this. This lady is a Norwegian cancer researcher, also well published in Nature and Science, and well known for her breast cancer expression patterns. She has looked at the expression patterns of so many different cancers, breast cancer, individual cases. And what she learns is that in the beginning, she thought this will give her the answer to the enigma of cancer, looking at the expression patterns. But what she finds is it gets more and more complicated the deeper into the science you get. And maybe we have been slightly naive to have this maybe slightly hubris ideas of simulating the whole metabolism. So let's look at what she's working with, cancer. You see this little tumor with the arrow here? It's spreading. And what is cancer? It's the opposite of human life. It's breaking down human life, so it's entropy. It's the overall entropy existing all over the universe, things breaking down towards more and more chaos and more chaotic equilibrium. So cancer deregulates, disseminates, invades, growth, and destabilize any system. So we need to think about it like that, I think. Another example, malaria, a very complex pathways between not only the host, not inside our body, but also with the microbe and the vector and the environment, that all of it influence the disease. Not only what's inside your body, but most important things are maybe outside your body. And you also learn that part of this infection is maybe protective. So it's not only a disease, it's also a kind of vaccine. And we see that the traditional approach to these drugs are very quickly becoming resistant. We see the same in tuberculosis, and we see the same interesting phenomenon in tuberculosis. Actually, most of the Norwegian and Dutch population was analyzed as tuberculotic in the way they were infected, but they're not at all sick. They were carrying the germ. So why are they not sick? Just a minority, a small minority really gets sick. So keep this in mind, and I'll give you the relevance for it later. But before we do that, look at malaria. We see now that a normal medical plant from China becomes the drug of choice. You don't even have to give it as a drug. You can drink it as a tea. And the plant even disperses the mosquito. The mosquito don't like the plant, so they stay away from the environment where the plants are. So if you plant those plants around the house, you are partly protected against malaria. And the good thing is that this plant can be grown by anyone. It's affordable and accessible. It's distributed. You don't have to go to a drug company or pharmacy to get it. You can plant it yourself. It's like your laptop. You don't need a big mainframe. You can have your own in the backyard. So maybe we need a global network for nature's medicine. Maybe we need research and clinical testing, distributed drug production, similar to the CGIAR that our good friend Ismail Sergeldin was chairing. That was part of the Green Revolution some time ago. So we need to learn about how we can develop these plant medicines and take advantage of the local control and use of these to make them into democratic drugs that we can control as patients. And we can own them as patients. They're available for all. Again, we also need to think more about health as negative entropy, exactly the opposite of cancer. Health is a miracle in nature because our body is a very organized principle in a fairly chaotic world where entropy is the basic principle. So it's against the law of physics that we are here and we are organized and that we are healthy. So we should look for what makes this work. What is the resistance in our bodies against all the diseases, against all the cancer? Why do we have this resilience? How can we recover so fast? Because we know every day we are probably attacked by cancer cells. Most of them are killed and stopped before. Every day we are infected. Every day we are carrying infections even, but we don't get sick. So our coping capability and our body's coping capability, to me, is more important than the disease from a public health point of view. We should look at our own resistance and resilience and our own sort of biological capital. How do we have all these resources to avoid this in our own body before any doctors come to help you? We don't understand much of this, but we can use these wonderful new tools that I talked about in the beginning to focus on resilience instead of focus on disease. That would be my advice to you young people here in Africa. Also, we need to get rid of this Western Cartesian mindset of dualism. There is a lot of good things you can say about René Descartes. He was an important guy in the development of the Western civilization. But now we have to put away his simplified ideas about how nature works. There is no difference between mind and body. Body and mind are two parts of the same entity. And it's a very destructive idea that the mind is separate from the body. His reductionist ideas have been very useful for science, but they are not sufficient anymore. He's very technology-oriented. I'm not so sure that this physical mindset, the physical model is relevant for life science, and I think we should try to get rid of it, because it also gives us this command and control attitude to biological phenomena, including patients, as you talked about, Alistair. If we sometimes feel like we are objectified when we come to the hospital and doctor talk about our liver, but not about me and my family. So this is a very strategic ambition. It's nothing wrong with it, but it's maybe not appropriate for life science, because there are some basic questions. Can we really understand the totality? I think we should try, but I don't think we will ever make it. Can we simulate it? Okay, let's try to simulate small bits and pieces of our own bodies, but don't let us believe that we can simulate our own brains. And I don't know why we should do it, because we have one here. We can use it instead of simulating it. And should we manipulate everything in the world? I don't think we should. We have a very instrumental approach to life and life science, and I hope we can go somewhere else. We need a new mindset, and one guy, Lawrence Lover, has proposed that we need to integrate this very ambitious modeling and simulation projects for all the gross data with a better understanding of how the individual organisms behave in an environment. That's obviously an additional thing we need to add. And then we will end up in something very evolutionary. And that's the science of how we became what we are. So we should be much more focused on evolution, both for analytical purposes and maybe also for pragmatic purposes. Evolution is a very practical principle. So through evolution, I think we can understand epidemics of communicable and chronic disease, and I will take a brief few more slides to explain how. So I think instead of a personalized predictive medicine, we need a preventive population medicine. We should not focus on the individual person. Why? Because we need to enhance the resilience and the coping capability, as I told you, and I think an evolutionary mindset can bring us there. We need to study whole organisms instead of the mechanism inside organisms. Take a stem cell. It does the whole job for you. We don't really understand how it does it, but we know this cell has evolved over so many years, and it's so versatile. And the stem cell can do a lot of things we wouldn't have clue how to do yet. So let's cultivate the stem cells. It's a whole organism, and evolution made it for it, and we can use it. So, and I say it's not health for all, because, like you said, Alistair, and not everybody can be healthy. And people our age, my age, I think we will have a hard time finding people on my age that has not been to hospital once. They will be able to give you 1 or 2 or 3 diagnoses of different kinds that they already have. So basically, health is very uncommon, but disease is very common. But we have to live with it. And the idea is not to get rid of all disease, but the idea is to have a good life, even with the disease we need to have. So I like to talk more about well-being than about health. So the alternatives approach can be more affordable and fair, at least if you can make democratic drugs that I indicated. And it can reach poor and privileged people at the same time, because it's a public health approach. It's not a personalized approach, which will never work in a poor country. It's too expensive, it's completely unaffordable, maybe even for the rich countries. And this more public health approach will create equity, not more diversity and disparity, It can also enhance your environment because you have to focus on the environment as much as on your own body. And it will develop the society as a whole and not only make silos of high-tech medicine for the privileged. And it doesn't stigmatize anybody by telling them they are sick and incomplete human beings because they have this disease or these genes somehow. So there is a diversity between two approaches. Biotech so far has been driven by a very technocratic ambition based on the physical science mindset. I think it's a kind of oversimplified analysis of system dynamics, like I indicated in the beginning. And it's also a very instrumental approach to life. It also has somehow very simplified economic inspirations. Lots of people want to make money on this, but for us doctors and patients, the important thing is to be well, to feel well, even if I'm sick. And that's a completely different thing. The money is the tool, not the goal. So, and when I talk about the hybrids of systems analysis, let's think about economics. It's supposed to be a very systemic kind of tool. They talk about the equilibrium in the economic system, and they have told us again and again that if you let it play freely, the equilibrium will take care of most complicated issues. And we have seen how it ended. This was a very oversimplified idea of a very complex system, and it failed dramatically, both intellectually and in practice. And I'm afraid we may go into the same kind of issues if we have the same over-optimistic ideas about what we can understand and simulate in medicine. So I want to go back to bioculture. We had great success with the Green Revolution. Nobody understood exactly what made those plants so effective, resilient to disease, high yields. But we were able to produce them anyway by evolutionary principles and by playing with the whole organism, not fiddling with their genes. We don't necessarily need to do that. And I tell you, it was not a technical revolution. It was a cultural revolution because we talk about agriculture. You culture the plants. You help them grow and become themselves in the most optimal way. And you work with both the ecology and climate, and you adapt the things to each other. So we see that this kind of approach is different. And I think it also fits very well with the new concept that in economics, collaborative efforts are more successful and more competitive than competitive advantages between companies. So companies tend to collaborate more. And even in innovation, I may guess Anatol will talk more about this. You talk more about open innovation, where you share intellectual property and you borrow and you sell intellectual property to share it with others that can combine your ideas and then you can evolve a bigger picture in a better way than being very focused on your own ideas. So this is my simple conclusion. Human health should be compared to a precious plant, and I hope many of the plant breeders here can appreciate this idea, and that we need to nurture it, cultivate it, and evolve it as a whole living organism, the kind of living organisms we all are. Thank you.
So allow me to start off with a few words to especially you, the students. Intellectual property, that's part of this talk. It has come up in this conference yesterday very briefly when a comment was made to our colleague from China on the sequencing of a cotton, long fiber cotton in China, and the question was there authorization to have appropriated that cotton for the purpose of sequencing? So that's part of the intellectual property system, this kind of question. But for you, the students, I would like to ask you, when we talk about intellectual property, what is it you think? What do you think about intellectual property? What is it? Sorry?
Not monopoly.
Not monopoly, okay.
Stand up, please.
Very, very briefly only, because it's more a didactical question than...
Well,
an exam question. But what is it? My question is just, what is it? What do you think? What is intellectual property?
Yeah, it is like monetizing ideas, monetizing the knowledge, monetizing information.
Okay. Someone else wants to try?
Yes.
One more try.
For me, it's the protection of the ownership of an idea of...
Protection. Very good. And the protection comes in different forms, patents. And there's an inherent trade-off. You disclose to the world what you invented. That's a patent. It's a full disclosure in exchange for a limited protection for a limited period of time. Another intellectual property is trademarks. Coca-Cola. Bibliotheca Alexandrina. This ark is a brand, so you recognize it. A third area of protection is trade secrets. If you don't patent and disclose, the alternative is to keep it to yourself and not to tell anyone. That's a trade secret. No, of course it's not the only alternative, but I'm just contrasting patents, disclosure, with one other form of protection, which is not to disclose to anyone. If I don't tell my ideas to anyone, it belongs to me. Maybe somebody else comes up with that idea as well, independently. Too bad for me. But these are the kind of intellectual property tools that are available either to monetize technologies, ideas, but also they can also be used equally efficiently in order to achieve humanitarian objectives. It is all a question on how those transactions, how we are using those tools, how we are using the assets, the intellectual property assets, in order to achieve something that we want to achieve. And very often, and that's the premise of my talk, very often those goals can be complementary. There can be monetization, commercial goals, and there can also be humanitarian goals with the same IP around the same technology. The question is how to manage that nexus, how to manage that interface. So that was more as a sort of very sideline introduction for students here, that intellectual property is neither good nor bad. It's not to be feared nor embraced. It's simply a tool. It's a knife to eat and cut your vegetables, or it is something to operate someone and make them healthy. But like many tools, they can also be used for other more sinister purposes. It all depends how we as individuals, or we as a community, or we as a global society wants to use them. In the World Intellectual Property Organization where I work now is or considers itself the guardians of the intellectual property system. Why? Because this is the place, WIPO is the place where the states, the countries like Egypt, the countries, the global community, negotiates the systems, but also where the treaties are implemented, like Patent Cooperation Treaty. So WIPO has certainly the trust of industry by and large, because we are the ones that facilitate filing in other countries. We are the ones that facilitate the copyright systems. In the IP in internet domains is litigated or, I should say, arbitrated or mediated at WIPO. So copyright, it spans through all these different areas. And then when I was hired, the question was, what could WIPO do in the area of global health, climate change, and food security? I'm going to talk about the health component today. My job is not to change the intellectual property system, is not to build capacity in managing intellectual property, but to come up with some platforms, some perhaps simple tools that enable industry in particular, those that have most of the intellectual property estate, and assist and develop mechanisms to make it more and more easily available to reach humanitarian objectives, without changing the system, without ripping anybody off, without telling anybody that they have been wrong, but to include and bring people, a constituency together. And what we have come up with over a year and a half, we launched last October the Consortium, a consortium of organizations that precisely try to achieve that. So I shall go through my slides very quickly, and now I need some help to know which button to press. This is like a keyboard, like a piano keyboard. Oh, I found it. So, here. So, Ypur Research, it's research. The subject is search, but it's also recycling, meaning applying IP that has already been developed for something in another context. And I would like you to just look at this line here. I've talked about patents, trademarks, and trade secrets. Thank you. Now I have more technology. This technology, at least I know how to use. Wow, it works. So, when you think of drug development, yes, the entire political debate and policy debate is exactly around the subject that you, whatever your name is, what is your name? Hamed, outlined. The tension of the haves, the haves not, the monopoly, the etc. Well, in fact, the much more valuable, the most expensive element in drug development, vaccine development, is the data, the know-how that is being generated. The regulatory dossier, a clinical trial, costs quickly $100, $200 million. That data, that knowledge that is accumulated is rarely transferred and shared outside a company. So what we have developed is a consortium that enables the sharing of precisely that kind of knowledge, regulatory data, but also compounds, compound libraries. Many companies have 10,000, 100,000 compounds as one library. Maybe they have 10 of those libraries. They've screened it once for cancer, for diabetes, for whatever, and then it stays in the attic or in the fridge in the basement. Yet a lot of data has been generated. Nobody uses that again. Why not make that available to someone who has a plausible hypothesis on how it could be used to treat some other diseases? And maybe the knowledge, the know-how, the platform technology, an entire lab like this space or more, to screen those compounds. Let's make that available as well. What about other know-how? Show-how, things that the scientists in companies know. Oh, and patent licenses as well, by the way. But I've put this last, and it's really the least important when it comes to neglected diseases, malaria and TB. So the consortium is a platform to enable companies in a trusted environment to open their intellectual property estates for a particular purpose. Ypur Research has 3 components: a database, and I will show a few slides in a moment, a partnership hub, because a database alone doesn't feed anybody. So we are working with partners who assist in the licensing and the deal making, and then some generic supporting services. All of this is aimed at making the transactions, the licensing, very efficient, transparent, low cost, which encourages participation by more institutions. It's a collaboration. WHO is involved. Many companies, Pfizer, GSK, Eisai, Novartis, just to name 4, MIT, Mahidol University, South Africa, Kenya, institutions in Brazil, Fiocruz, not yet in Egypt, but I hope soon, and of course academics. A growing list of members. We have providers, those that provide intellectual property, those that have initiated negotiations on accessing intellectual property, and then a number of organizations that lend support in different forms. At the moment, 42 members, and the list is growing monthly. So when a company or anyone makes intellectual property available in the database for licensing, there are some simple terms that they have to agree to. Royalty-free for anywhere in the world, for research, development, and manufacture. Royalty-free license for sale of products in least developed countries. Agreement to negotiate in good faith. Access to all developing countries under agreed terms. If there are diseases that afflict mainly the poor, I think most licenses will be royalty-free there as well. If it's maybe dual market, malaria, TB, maybe dengue in some cases, there might be a license with different terms for different groups of access, public sector supply versus private, but let's develop them as we go along. So fairly simple, transparent terms as the minimum terms that companies agree to license. The minimum terms. It can always be better. No reach-through, etc. I think the key points are here. I have these guiding principles in Arabic, in English, in French, Chinese, Spanish, French, and a few other languages. A database is the starting point. A scientist searches, and it's built, structured in a way that enables scientists to ask questions. So we started off with, we talked to 100 or so scientists. How would you want to search what is out there, whether there's something out there that responds to your hypothesis? So there are about 180 possible ways for searching. Not every entry has all the 180 characteristics, of course, but it enables a very broad base of scientists to search for it. Just one example, you can then dig down by provider, by type of IP and so forth. But I shall leave all of this for another talk when I have more time. Maybe I'm coming to the university and will fill you in. There's also a brochure on the table there. You can also go to the website, and you can search yourself. The database is freely accessible because it does not contain the IP itself. It contains a description of what is available for licensing. Now, I have a few more minutes, 5 or so minutes. The key challenge, of course, with Ypur Research is, well, initially at the moment, it's to build still the consortium, to get the first licenses going, to enhance and enrich the database. But all that is, in fact, some linear thinking. It's based on somebody has something of value, we put it in a database, somebody else comes and looks for it, and then gets a license and goes and runs with it. We've heard a lot in the last day or so about all this tremendous wealth of data that is out there. Well, we've already come across this bottleneck, so to speak, when companies said, well, we have libraries, we have 24 libraries, but we have data, but the scientists no longer work on it. We don't really know where the data is, but while it's in an access file, but it's very big, and we don't really have the manpower or woman power to look into that database and make it available for you. But if you find a way to do it, by all means, do it yourself. So the challenge is now coming. How do we mine tremendous amounts of data that are proprietary in many cases, if not in most cases, as well as public data? NIH is a member of Ypur Research and is thinking with us through these issues. How can we use all that data that is public but not really accessible? It's available but not accessible, because to distill it is something to make sense. To build the knowledge, extract the knowledge out of it is a tremendous challenge. So this will be the next year and a half when we will think through how can we develop a systems approach to mining that kind of data, and then to make it available to enhance existing research and encourage new research that would not otherwise have taken off. In the last 3 minutes, I will share with you another idea of another platform, down to earth, and it's related to this debate. In fact, you were the ideal person, by the way, to respond to my partly rhetorical question. And that is, there's a model list of essential medicines. WHO produces every 2 years 350, 400 drugs that every country, every hospital should have to be operational. And there's a big debate in Geneva. It's been going on for decades. Oh yes, but there are patents. Patents limit access and so forth. And it's been shown by others and recently by us again that only 10% of those medicines are patented, and yet they still don't find easy access in all the corners of the world. So there's this debate, this policy debate. The underlying evidence is very often quite different. But let's make all this information available, but then go a step further and encourage those medicines where there are patents for them to be licensed, for everyone to know what really is the situation in a given country around a particular medicine. And that's what we call Ypur Essential. It's the model list of essential medicine as a starting point, but we're also talking about the essential or the base patents for those medicines, and it's really an essential platform, I tend to think. It's not launched yet, so this is a pre-launch dialogue, partly also because we are looking for partners to work with us in order to make this successful. Very briefly, it allows users to go to the website and search by jurisdiction for a particular country, Egypt, and then see which medicines have patents, where have we found patents, or by medicine and see what is the geographic distribution of patents for that medicine. And you can also find out who is the assignee or the applicant of that patent and maybe go and get a license if you want to. But then that information, that data is rarely current. As soon as it's published, it's out of date because patents evolve, are dropped, new patents are filed and so forth. So we are including a social networking space where people from MSF to any law firms or original invented the companies themselves or the generic companies can go there and say, but this patent has been abandoned. There's another patent that is also relevant. You've missed it. Oh, and this particular patent in Egypt, because the claim construct is different and interpretation is different in Egypt, does not apply for this particular medicine. We can't really know all these things in all the countries of this world. So with that social network, we believe it is a mechanism to get all that information, to have everyone collaborate and allow us to put that information current. It is a very risky, somewhat of a risky endeavor, because it's sort of borderlines of legal advice, which we are not giving. It has disclaimers. And yet, for Ypur, for a UN organization, this is a pretty risky project, but I think extremely exciting because it's really a new way, leveraging Facebook. I don't mean we are not going to use Facebook, but leveraging that social network that the Web 2, in fact, has enabled us to do. And people can also request information on new medicines that are not on the list, and you can see the arrows, but then also how will we fulfill those requests is precisely by, again, using that network, that social network, to find the answers and put it back into the database that allows others to browse and get that new information. It's not launched, as I said. We will have a pilot version at the end of May, which we will be testing with procurement agencies, and then launch this later this autumn. But I wanted to give you a preview because we are reaching out to patent offices, to law firms, to companies, and so forth, and also to students, incidentally, because a lot of the work initially was done in collaboration with the Franklin Pierce Law School, Sandra Day O'Connor College of Law, also, where in fact students use this as a semester project, and that data then forms the basis of Ypur Essential. Thank you very much.
Thank you.